Okay, so in terms of content for higher, the laws of indices question is higher only, so that's going to be second half of the paper, as is bounds, as is difference of two squares, changing subject of a formula, that's actually on the foundation content, so we can expect it to be an easier rearrange rather than one of the more difficult rearranging where you've got two of the same letter. Algebraic fractions, the quadratic, simultaneous equations, iteration, circle theorems, 3D trig, column vectors, the probability and histograms. These are all definitely the second half of the paper, so the more difficult style question. In terms of predicting the kind of questions that we might see for these questions, I think difference of two squares, the factorising that type of quadratic, is probably going to be within the algebraic fractions question or another question, or perhaps just a standalone factorise. The trig in 3D, I think, will be, so the SOHCAHTOA, the trigonometry here, so it hasn't listed sine and cosine rules, so we can just expect it to be SOHCAHTOA with 90-degree triangles. Pythagoras, possibly a standalone question, but could also appear within the 3D trig question or area of a trapezium. Now, you do get the formula to find the area of a trapezium, so you don't need to learn it. You do get that on your equation sheet, but we have seen before an area of trapezium question where you have to use Pythagoras to work out, say, the height of the trapezium. So it could be Pythagoras embedded in that style question. So I'm going to start with laws of indices in terms of the more difficult style question. So in the previous warm-up lessons, we've looked at kind of these style questions, the simplifying with indices, the easier style questions. But I kind of think something like this will come up where we use base numbers. So what we mean by that is if you see the number 8, you also have to realise that 8 can be written as 2 cubed. So it's working backwards. So for example, 1 over 81 is a single power of 3. Now we recall from laws of indices when we've got the 1 over, so if we have a negative indice, that tells us to find the reciprocal. So that would be to the power of 1 because that's the 1. The negative implies that we make it the reciprocal. 81, yes, is 9 squared and 9 is 3 squared. So 81 is 3 to the power of 4. So we want to write this as a single power of 3. So we've been told the base number that we want. And then because it's 1 over, that's your negative indice. So we make it 3 to the power of minus 4 is 1 over 81. Similarly, we'll look here, we've got 32 and 16. So in terms of base numbers, because we want to solve, so we want to equate left and right so we can set the indices equal to each other. So the base numbers, you might think, okay, maybe I'll make it 4 because 4 squared is 16, but you can't do 4 to the power of something to get 32. But what we can do is make them 2, the base number's 2. 2 to the power of 5 is 32. So I'm going to change 32 to 2 to the power of 5. The 1 over 16, I'm going to write 16 as 2 to the power of 4. So we've seen this 1 over the reciprocal, and we know that when we've got these indices with brackets, we multiply. So to simplify this further, that's 2 to the power of 5x equals 2 to the power of minus 4. Now our base values are the same, that is to say 2 to the power of 5x is 2 to the power of minus 4. So we can equate our indices. 5x equals minus 4. Divide the 5, x equals minus 4 over 5. And leave it as a fraction or simplify that decimal. I'll do one more. I'll just leave that there if you wanted to take a quick screenshot or photo. So then looking at D2, so 2 to the power of x equals 8 to the power of 1 over 4 times 16 to the power of a third. So because this is a calculator paper, you can't actually, solve this with a calculator, which is why I think one of these style questions will come up in terms of indices. So 2 to the power of x, our base number is going to be 2, because that's the lowest one that we see here. Instead of 8, I'll write that as 2 cubed. So that's 2 cubed to the power of a quarter. And then I've got 16, and instead of 16, I'm going to write that as 2 to the power of 4 to the power of 1/3. Get these out of the bracket, so that's 2 to the power of x equals 2 to the power of 3 over 4. 3 times a quarter is 3/4, times 2 to the power of 4 over 3. Now I use my indice rules that when the base numbers are the same, I add my indices. So I've formed an equation, x equals 3 over 4 plus 4 over 3. Then you can chuck that in your calculator, 3/4 plus 4 over 3, 25 over 12. Leave it as a fraction or as a decimal. Just to recall, anything to the power of 0 will be 1. To simplify here, this is only 1 mark, so if we've got squared at the bottom, that means we've got 2 lots of the x minus 4, so that x minus 4 at the top cancels out. So we're left with one of the x minus 4s on the bottom and an 8 on the top. We had to simplify these indices, that's 3 cubed, which is 27, and then we multiply out the indices, n to the power of 12, w to the power of 6. Okay. Then we've got bounds. So I've picked a difficult bounds question here. So this is probably what we'll see towards the back end of the paper. Sorry, 1 second. Right, so bounds. By considering bounds, what we mean by that is find both upper and lower bound of our t. To a suitable degree of accuracy, that means we're going to round our answers to the greatest number of significant figures possible, where they both give us the same value. This will make more sense once I've done the question. So, t equals m divided by f. Find the upper bound of t and the lower bound of t. Now, because it's a division, we have to be careful. So you always have to consider, when dealing with bounds, what's going to give me either my greatest or my lowest possible value of t. So if I want the biggest slice of cake possible, I want to do a big cake divided by, shared between, the least number of people. So if it's a division, I'm going to use my upper bound of m and I will divide that by the lower bound of f. So vice versa, for the lower bound of t, I'm going to do my lower bound of m divided by my upper bound of f, because that's going to give me the smallest possible value when I've got a large denominator. So also be careful, I looked at a question yesterday where we dealt with Pythagoras and we were doing bounds with Pythagoras. Now we were trying to find a squared and we wanted the upper bound of a. So because a squared gives me c squared minus b squared, and I want this to be the biggest value possible, I do the largest value of c, and then I subtract the lowest possible value for b, the lower bound of b. So just bear in mind, it's not always, to find the upper bound, you only use upper bounds. It may be a combination of both. So kind of just think about a bit of common sense there. But even if you did put in the wrong value, but your method's correct, you'll only lose 1 mark. So let's find the bounds. So we've got m is 120 correct to 3 significant figures. So I'm going to use my scale and I'll say, what's my next number to 3 significant figures? 121, and the previous 119. So be careful what we're rounding to. So if this was to the nearest 10, then it would be 130 and 110. So just be careful with what we're saying here. Then the bounds go between. So the upper bound is 120.5 and the lower bound is 119.5. So upper bound of m, 120.5, lower bound of m, 119.5. Lower bound of f, so I've got 25.6 to 1 decimal place. My next number to 1 decimal place is 25.7 and my previous is 25.5. My bounds go between. So my lower bound for f is going to be 25.55, my upper bound 25.65. Chuck those in your calculator, so 120.5 divided by 25.55. We want to write down all decimal places for our bounds. So if they don't say round to a suitable degree of accuracy, and it's a bounds question, you write all decimal places out. Then my lower bound, 119.5 divided by 25.65. 4.6588693996. The last part of this question is to find t to a suitable degree of accuracy. So I look at both answers. I'm considering both my bounds. 4.716, 4.659. So 4 significant figures is too many, they're not the same number. 4.72, 4.66, still not the same number. So if I go to 2 significant figures, 4.7, 4.7, because that's a 5, so I'd have to round. So my value for t is 4.7 because it's the greatest number of significant figures in which both answers rounded give me the same. So that could be a 4 or 5 mark question, depending on the formula that you're using. Take a screenshot of that if needed, and then I shall move on. Product rule for counting. Obviously, we're not going to get told it's a product rule question, but this is all about combinations. So the PIN codes, you've got a 4-digit PIN code. How many possibilities of PIN codes can we have? Work out the number of different ways. Work out the number of combinations or possibilities. If it's that, it's product rule. Product means to multiply. So Mrs. Atkins is going to choose two students from her class to take part in a competition. She can choose from 16 girls and 14 boys. The number of ways of choosing 1 girl and 1 boy, so you've got a choice of 16 girls and 14 boys, so you just multiply those numbers together. 2, 2, 4. Work out the number of ways of choosing 2 boys. So I've got a choice of 14 boys for choosing the first boy. Then I've chosen one of those boys, so I've then got, for the second boy, I've only got a choice of 13 boys left. So I take one off. 182. It could be I've got 6 starters in a restaurant. I think that there are 24 different ways of choosing a starter in a main course. Could I be correct? Starter and main. I probably shouldn't have put a plus there. And main. So if I've got 6 starters on a menu and I'm saying there are 24 different ways that I can choose a starter in a main course, well, 6 times the number of mains, because that's the starters, equals 24. So the number of mains are 4. So yes, I could be correct because I get a whole number. If it were a decimal, then no, because I can't have a decimal number of main courses. Difference of 2 squares. Now, because on the list it doesn't say factorise, I feel like it's going to be a difference of 2 squares within an algebraic fraction question, which I'll come on to. But just bear in mind, if we've got ax squared minus c, that's still a quadratic. It still goes into double brackets. The tell, what we're looking for is that that's squared, that's a square number as well. So it's x plus 4, x minus 4. You can always check the factorising of when you factorise anything, you can always double check by expanding it out, and then do you end up with the original thing? So essentially you just square root anything. So if I've got x squared minus y squared, and I wanted to factorise that, that is still a difference of 2 squares. That would be x plus y times x minus y. If I had 9x squared minus 25y squared, that's a square, that's a square, that's a square, that's a square. So it's difference of 2 squares, or dots, some people call it. So I square root everything, 3x, 5y, 3x, 5y. One's positive, one's negative. Difference means to subtract, which is why one's plus, one's minus. Change the subject of a formula. So because this is common with the foundation content, I think it's going to be more like one of these as opposed to one of these, but I will do both. Make y the subject. So y, we're adding m and then dividing by 4. So I work backwards. I times the denominator over first to get 4d equals y plus m. Then to get the y, I want to take away the m, so 4d minus m equals y. Same first step here, always times over that denominator. So f bracket 5 plus m equals 4 minus 3m. Expand, 5f plus mf equals 4 minus 3m. So this is like a 4 marker, and this is normally the higher content of rearranging because there's an m here and an m here. It involves factorising at some point. So at this stage, I've got 2 lots of m and they're on opposite sides of the equals. I want to get anything with an m on the same side. So I'm going to add 3m. So I get 5f plus mf plus 3m equals 4. The aim is to get m to be the common factor. This doesn't have an m, so I'm going to take it away to leave me mf plus 3m equals 4 minus 5f. Now m is the common factor on the left-hand side. I can factorise and take the m out. F plus 3 in the bracket equals 4 minus 5f. Now I can divide that bracket because that means to multiply, so I divide that bracket to get m equals 4 minus 5f over f plus 3. Like I say, that will be a 4 marker and we don't normally see that on the foundation content, so I don't think it's going to be a rearranging that difficult. I think it's more going to be like this, but you never know. Algebraic fractions. So we could have a simplify with algebraic fractions, or it could be an equation with algebraic fractions. Either way, if it's a more complicated version of this and you've got something like this times something like that, your first step is to factorise, and that's why I think that difference of 2 squares is in it. So if you've got a, you know, something that looks like a quadratic times another quadratic or add it, factorise first. So always look, algebraic fractions, can I factorise? That's your first step. If not, and you're just adding them, then you just move on to making denominators the same. So let's do here, we factorise top, factorise bottom, so 2x plus 3 times 2x minus 3, that's a difference of 2 squares, because it's square, square, square. Factorise the bottom. If you haven't learnt the AC method for factorising, where you do 2 times 12, 24, 2 factors of 24 to add to get 11, etc., I suggest you type into YouTube AC method. So I know I'm going to get 2x and x, or you can just do it by trial and error, but I wouldn't if you're not very good at factorising. But you can, because it would just take a bit of time, but you can expand and check. Now, to get me 12, my factors are 4 and 3, 6 and 2, 12 and 1. Now, I've got to bear in mind whatever I put here is going to double, because when I expand, that gets multiplied by 2. So I think ahead about that. I also think, well, one of my brackets has to be the same as the top. So I'm going to go, that's going to be a 3, that's got to be a 4. Now I work on my signs, 2x times 4, and then I'm timesing by 3x. So I get 8x plus 3x. So they've both got to be positives. Those two cancel, leaving me with 2x minus 3 over x plus 4 as your final answer. The next one, think about what you would do if it were just a normal fractions question. If it was 3/5 plus 4/8, you'd make the denominators the same. So we go the same. This one, this first fraction, I'm going to times everything by x minus 3. This fraction, oh, that one, I'm going to times it by x plus 2. So 3 times x minus 3 over x plus 2 times x minus 3 plus 4 times x plus 2 over x plus 2 times x minus 3. That all equals 2. 3x minus 9 plus 4x plus 8. I'm just looking at the tops for a minute. That's all over x squared plus 2x minus 3x minus 6. I'm adding, so 3x plus 4x is 7x over, oh sorry, not finished. Minus 9 plus 8 is minus 1. And then that's over x squared minus 1x minus 6. Now this is equal to 2, so it's a solve question. If it's equal to something, you can find the value of x. It's a fraction, first step, times that denominator over. 7x minus 1 equals 2x squared minus 2x minus 12. These are my quadratic eyes. What you want is always be on the lookout for something that looks like a quadratic, especially if it's a solve question. A quadratic, we have ax squared plus bx plus c. We can solve by either factorising or using the quadratic equation. You can only solve quadratics when they're equal to 0. So I take the 7x and I add the 1. That gives me 2x squared minus 9x minus 11. That's a quadratic, so see if we can factorise. I know it's got times to get 2x squared, so it's going to be 2x and x. And then luckily 11's prime, so I know my brackets can only be 11 and 1. Then I want a combination that's going to give me take away 9. So if I put the 11 here, that gives me 22 minus 1. That's never going to get me minus 9. So if I put the 11 here, I get 11x. And then I get the 2x here, and I've got to get minus 9. So that's minus 11x plus 2x. So it's a solve. it's equal to 0. I set each bracket equal to 0. So that means 2x minus 1 equals 0, x plus 1 equals 0. Add the 1, so 2x equals 1. Sorry, that's 11. 2x equals 11, and then divide by 2, x equals 11 over 2. Again, decimal or fraction doesn't matter, it's still mathematically the same thing. Or x equals minus 1. So actually quite a long-winded question. Take a screenshot of that. This PowerPoint is on the Google Classroom area, so there is another one for you to practice, which I'm happy to mark, or if you've got any questions as you're doing it, feel free to just drop me a message. Moving on. So what we see here, quadratic, linear, quadratic, linear. I don't think this is going to be a graph question because it's not in the graph topic, it's in the equations list. So what I mean by that is the pre-released information, the simultaneous equations is under the algebra topic and solving as opposed to the graph topic. So I don't think you'll be solving this graphically, I think you'll be solving this algebraically. So if I've got a straight line, my linear equation, it can either touch the curve and there be one coordinate as a solution, or my straight line can go through my quadratic, the quadratic being the U-shaped curve, and I'm going to have two solutions. So I'm either going to have a line that intersects the curve at two places, or I'm going to have a tangent to the curve. So just be aware that they could also do this in terms of a worded question, as opposed to just listing you two formula. What I mean by the worded question, it might be the curve 2x squared and the straight line y plus 7x equals 15 intersect at two places, find the coordinates of intersection. So you might think, what on earth? All it is write them out one on top of the other and we're solving them simultaneously. Now, we can use the substitution method. Y is 2x squared. So in place of y here, I'm going to substitute in 2x squared. So that's 2x squared plus 7x equals 15. There we go, on the lookout for a quadratic. To solve, it needs to be equal to 0. 2x squared plus 7x minus the 15 equals 0. Factorise to solve. 2x, x, 5 and 3, because that gives me 10x. So plus 10x, take away 3x. Minus 3 times positive 5 is minus 15. Obviously, I'm going through this very fast to try and get as much content revised as possible. So if you take a bit longer to factorise something, do not compare yourself to me factorising something. Take your time, check it, make sure you've got it right. Be careful of your signs, double check the signs. So now I'm going to set each bracket equal to 0. So x plus 5 equals 0. That means my value of x is minus 5. And then 2x minus 3 equals 0. Add the 3, divide by 2, x equals 1.5. These are my two x coordinates. So I need to find my y coordinates. So with normal simultaneous equations, you substitute in your known values to find out the values of y. So we just do it twice because we've got two values for x. So y equals 2x squared, we're going to sub in the minus 5. Be careful, minus 5 squared is 25, times by 2 is 50. So don't just chuck it in your calculator because your calculator will go minus 5 squared minus 25, which is not correct. So I think when I said about this last time on the paper 2 question with the quadratic inequalities and finding the square root of a number, you could also have the negative version. I think that came up as like the last question on the paper 2 with the quadratic inequality. So then I'll sub in my 1.5. 1.5 squared is 2.25, and then times that by 2, 4.5. So y equals 4.5. So they are my two coordinates of intersection. With this one, it looks slightly different. They're both equal to y. So if y is 9x plus 2, you put it in place of there. So you just say 9x plus 2 equals x squared plus 7x plus 3. Same thing, you want to make it equal to 0. So take the 9x, take away the 2, factorise, solve for x, substitute in. Gradient of a straight line, rise over run. So draw your triangle wherever best you can. So we do the rise, find out the change in the y divided by the run. I think you get 0.45 when you do this, just because I did it yesterday. But what I wanted to focus on this is, what does the gradient represent? So interpret the gradient. If I'm doing the rise over the run, you look at your units. So rise divided by run is kilograms divided by pounds. So my 0.5 actually means 0.5 kilograms per pound. Even if you just wrote kilogram per pound, that's shorthand for pounds. If you just wrote kilogram per pound, you would get the mark for that. So just bear that in mind. Rise over run, just sub it in for the y and the x axes. So that means 0.45 kilograms for every 1 pound. That's your conversion. Okay, depreciation, higher tier question. So it could be something as difficult as this. This one is a bit like compound interest, but the other way, we're reducing it. So depreciation means we're losing a particular percentage as opposed to adding it on like interest. Peter pays £5,000 for a factory machine. The machine depreciates at a rate of X% per annum. So we're actually losing money on this machine. It depreciates, so we're taking away that percentage. I don't know what that percentage is, so I'm going to call it X. I'm doing it for 6 years, and the value at the end is £3,493.62. I want to try and find the X. So I'm going to divide by 5,000. 3,493.62 divided by 5,000. X to the power of 6 gives me 0.698724. Now, if I had x squared, to do the opposite of squaring, you square root. So to find out x, I'm finding the 6th root of my answer. So just be sure you know where that button is on your calculator. It's the shift and then the x to the power of. So hopefully you can see that. There. So shift that button, put the 6 at the top, and then just the A and S button to sub in your answer. So x equals 0.942 ... Now, that isn't 0.94%, so be careful. To get it as a percentage, I times by 100, so that's 94.2%. Now, that means my machine is worth 94.2% of its previous value every year. So I'm going to do 100 minus that answer to give me 5.8%, which will be the depreciation. It's lost 5.8% every year. So if, for example, so depreciation could also be, something in the sale. It depreciates in value. You're losing value. I think it will be a more like a question like this, but just to show you how to work out the multiplier. The original price is 100%. I'm reducing it by 20%. Therefore, my sale price is 80% of the original value. So if the normal price is £180, that 80% is the sale value. So if I find 80% by doing 80 over 100, which is 0.8, so 100 times 0.8, 180 times 0.8, that gives me 144. So that's one method of doing it. Obviously, you can do your 10% method, double it, find 20%, take it away. But I much prefer this. 100% is the original value because it helps in reverse percentage. So in a sale, all prices are reduced by 15%. My original price is 100%. My sale reduces by 15%. So my sale value is 85% of what the original price was. The sale price is £22.40. So my sale percentage of 85% is equal to £22.40. So this is a bit like using ratios. If I've got 85%, if I can find 1%, so £22.40 divided by 85, that gives me 0.2635. I can then times that by 100 to get my original 100%. So just be aware, you can then also check that answer, so £26.35. If I found 15% of that and took it off, I would get £22.40. So reverse percentages you can check. Percentages, you cannot just find 15% of £22.40 and add it on. It doesn't work like that, because 15% of that is a different number to 15% of the original price, because they're different amounts. I'm skipping some questions. I'll get on to iteration. So just an average speed, units. So speed, distance, time. I'll do this one. This one, the units are okay, so probably a bad example for me to pick. But if I'm looking at an average speed in kilometres an hour, that means my distance is in kilometres and my time will be in hours. So just be aware of first consider the units that you're given. 1 hour is 60 minutes, so our conversion always have in our mind to go minutes to hours, you divide by 60, hours to minutes, you times by 60. So if I was told, you do a race and it takes you 1 hour and 18 minutes, that is hours and minutes, that's not hours. So first put in minutes is 78 minutes, divide that by 60 to get it into hours, 1.3 hours. Then you can use that number in your speed, distance, time. In terms of this question, Andy cycles a distance of 30 kilometres at an average speed of 24 kilometres an hour. He then runs a distance of 12 kilometres at an average speed of 8 kilometres an hour. Work out the total time it takes. So we go time for the cycle, time for the run. Time, distance over speed. 30 kilometres over 24 kilometres an hour. 30 divided by 24, 1.25 hours. Time for the run, 12 divided by 8, 1.5 hours. Total time, add them together, 1.75 hours. So I could do 1.75 times 60, that gets me in minutes, then I put that minutes and hours, or if you know that 0.75 also is 3/4 as a fraction, that means 3/4 of an hour and 3/4, so 1 hour and 45 minutes, because the question wants it in hours and minutes. There's also a button on your calculator. So if I've got something in hours, oh my God, 1.75, there's this button here, the one that looks like a load of commas. You put in 1.75 equals and then press that button, it gives you it in hours, minutes and seconds. I don't really find it that useful, to be fair. I'd rather you learn how to do it, the conversion. Iteration, other style iteration questions. So we can look like this, or we can look like the population of bees in 2010 is 200. Work out the population of bees in 2015, something like that. So it could be about population growth, or it can be just in terms of X and we're doing sequences. So, easy way to think about iteration is whatever number they give you, substitute it in. So here's my iteration formula. Looks awful, looks complicated. All I'm doing is I want to do this once to find an estimate for this question. This bit's not iteration, it's just rearranging and stuff. So if x to the 0, if x0 is 1, that's to say x0 plus 1 is x to the 1. So to find x to the 1, I put in 3 times x to the n, so n being 0. I put in my number, chuck that in the calculator and write down what I get. So whatever number they give you in the question, whatever it's equal to, you substitute it in your formula. So the population of bees in 2010 is 250. Iteration is a formula where you can then use an equation to find out the next value in the sequence. So you can only go next value, next value, next value. You can't jump to 2015 in one step. So to find out the population in 2011, I substitute in 250 here. Calculator skills, 1.2 bracket, 250 plus 50 equals. So we go like that. So 2011 is 360. Population in 2012. Now, iteration, you press the back arrow, delete the 250, press the ANS button. That substitutes in your previous answer. Press equals, 492. Press equals again. That gets me my population in 2013. And so on and so on. The more you keep pressing equals, that gives you the next value in your sequence. Hopefully that made sense of iteration. That was quite fast. It was just like a shortcut way to do iteration. Just if you're confused by it, just substitute in whatever number they give you into whatever formula they give you. Trapezium area, you get given the formula. That's the foundation. So it should just be a pretty straightforward find the area. Similar shapes. So mathematically similar shapes, key points, all the angles on the inside of the shape are the same. The lengths are different by a scale factor. So our shape might be twice the size or 3 times the size or whatever. This question, A to B, P to Q, is in the ratio 2 to 5. So 2 to 5, A to B, P to Q. So if that's 9, think what have I done to 2 to get to 9? Normally you'll be given a common length and you can just divide them to find the scale factor. But this one's in a ratio, which I actually haven't seen before, but we move. So I'm timesing by 4.5. So I do 5 times 4.5. to get 22.5. Now, normally you'd get one of the same lengths on the two triangles. Just be aware, sometimes they put the triangle within a triangle, and this big triangle will be similar to the smaller triangle. So this big length is similar to this length, this big length is similar to this length. So, to find the scale factor, 22.5 divided by 9, it's got to be the same length. It's got to be the corresponding. So the scale factor here is 2.5. So I know this triangle is 2.5 times the size of this triangle. Work out the length of BC. So if this is QR and I'm trying to find BC, I know that this triangle is 2.5 times the size, so I divide now by 2.5. So I do 18 divided by 2.5, my scale factor, to get a length of 7.2. Also, with similar shapes, we can see three-dimensional shapes. So just bear in mind what we've looked at here is everything to do with lengths and your scale factor. So length scale factors, if I call it x, in this case times 2.5, but it might be twice the size or 3 times the size. If I were then dealing with area and I've got, say, the area of this shape, find the area of this shape, I'd use my length scale factor, but it would be squared. So in this case, if I knew the area of the small triangle, I would times that area of the small triangle by 2.5 squared. If it was volume, you'd do the scale factor cubed. So similar shapes can be used in 2D or three-dimensional shapes. That's the key points with similar shapes. But it does specifically say similar triangles, so that makes me think it's not going to be the three-dimensional scale factor for length, area, volume. I reckon it's just going to be maybe a triangle within a triangle or two triangles next to each other. 3D trig. 3D trig isn't as bad as it looks. You've just got to pick out the correct 2D right angle triangles. So base ABCD of a prism is a rectangle. Now it's a rectangle meaning this side is 8, this is 8, this is 4.5, because it's the same as that. We've got right angles. M is the point on DA such that D to M, M to A is split in the ratio of 3 to 2. So we are splitting 8, so if M is there, we're splitting 8 in the ratio of 3 to 2. So we go 8 divided by 5 times by 3. So D to M is 4.8 centimetres and M to A is 3.2 centimetres. Calculate the size between EM, so I'm going from E and I go to M, and the base of the prism. So the base of the prism, like that. So E, B, M is the triangle I'm looking at. I'm looking for this angle here. At the moment, I don't know any lengths on this triangle. But can I find anything out? Yes. I can find out this length here, the height. So EB, because I've got this right angle triangle here. So this is where I think Pythagoras will come into play. So EBA, this bit here, base is 4.5, the hypotenuse is 5.3. So I can find EB because it's common to both. A squared plus B squared equals C squared. Key point with Pythagoras, your hypotenuse is C. So I'm doing, to find this one, 5.3 squared minus 4.5 squared. Square root that answer, 2.8. So 2.8 is EB. To find out an angle, I need at least 2 lengths to use SOHCAHTOA. So I'm looking for another right angle triangle. If I was looking bird's eye view down, here, 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 if I was looking base down at that, that's a rectangle, that's a right angle. So BAN, there's my 90 degrees. BAN, I know A to M is 3.2, I know B to A is 4.5. If I find B to M, it's common as the base of this triangle. Again, this is another Pythagoras, but this time we're finding the hypotenuse. So 4.5 squared plus 3.2 squared, square root that, I get 5.5217 dot, dot, dot. So there's my triangle, I'm finding this angle here. So if you know how to do SOHCAHTOA, you should be able to just piece it all together to do 3D trig. Opposite, adjacent. So I'm using TOA. I'm finding the angle. So finding the angle, we do the inverse tan of the opposite over the adjacent. So that's the inverse tan of 2.8 over my answer that should be in my calculator, so we don't need to round, you just put in the ANS. Shift tan 2.8 over the 5 point blah, blah, blah. So I get an angle to 1 decimal place, angle equals 26.9 degrees. So if you do know how to do SOHCAHTOA, I would suggest, so SOHCAHTOA and Pythagoras, definitely have a crack at the 3D trig question. It will be towards the back. But what you're doing is you're looking for a minimum of 2 2D triangles to find out whatever it is that they're asking you. I'll do one more question. Probability. There are only red sweets and yellow sweets in a bag. There are n red and there are 8 yellow. So that means, say, probability of red is n over n plus 8, because that's the total number of sweets. And then the probability of yellow will be 8 over n plus 8. He says the probability of the sweet is 7, of picking a red sweet is 7 over 10. Show why this cannot be true. So, probability of taking a red sweet, n over n plus 8. And we're saying that is going to be equal to 7 over 10. Now, fraction equaling a fraction, algebraic fractions, what we do, we cross multiply. So that's 10n equals 7n plus 56. Take the 7n, that's 3n equals 56. N equals 56 over 3, which is a decimal. And I cannot have a decimal number of sweets. Part 2. 2 sweets from the bag, and he's eaten it. That means he's not replacing that sweet. That sweet is gone. This is the conditional probability. It changes the probability of what you're going to get for the second pick. So if you take 2 things at random, you're not replacing it. So probability of taking a red sweet, n over n plus 8. Probability, here, that's then 8 over n plus 8. I'm only interested in both sweets being red, so I'm going to say n minus 1 over n plus 7. I've taken 1 red sweet, so I've got 1 fewer red sweets, that's n minus 1. I've taken one sweet from the bag, so I go down to n plus 7. Both sweets are red, so that means red and red. So n over n plus 8 times and rule and or rule. When we use and in probability, we times. When we or, we add. So if you had like red and yellow or yellow and red, you would times those probabilities, then add them. Times n minus 1 over n plus 7, and I'm saying that is equal to 3 over 5. Times in fractions, we times straight across, so that's n squared minus n over n squared plus 15n plus 56 equals 3 over 5. Cross multiply, 5n squared minus 5n equals 3n squared plus 45n plus 168. Quadratic, that is a quadratic, so we make it equal to 0. Take the 3n squared, so 2n squared. Take the 45n minus 50n minus 168. You can factorise that, or I'm just going to divide them all by 2, just to make the factorising easier. So I'm looking for two numbers that times to get minus 84, but add to get minus 25. (28) and 3. So n minus 28, n plus 3 equals 0. So minus 28 add 3 is minus 25, minus 28 times plus 3, minus 84. Set each one equal to 0. So n minus 28 equals 0, so n could be 28 or n could be minus 3. N cannot be minus 3. I cannot have a negative number of n red sweets. So I have 28 red sweets. Take a screenshot of that. And there we have it.